Yeah, good afternoon, everyone. Today we are very happy to be with Dr.Alain Ndoli. Ndoli is the Senior Program Officer at the International Union for Conservation of Nature, IUCN, in Rwanda, with expertise in soil science and specialization in agroforestry and integrated soil fertility management. Today's presentation will be focusing on disentangling the position and negative effects of trees on maize performance in smallholding of Northern Rwanda. So, dear Alain Ndoli, you are welcome for the presentation, and participants can be writing questions, suggestions in the chat room. They can also ask questions after your presentation. You are warmly welcome. Thank you.
Thank you very much, Fernand. I don't have the rights to share the screen. I don't know if you can give me rights or present on my behalf.
Sorry, I'll fix that right now.
Thank you.
Okay.
If I can figure it out. You'd think after all this time we'd be Zoom experts. Where are you, Ella? Okay, I just tried something different. I made you a co-host. See if you can do it now.
Okay. Yes, I think now that one will work.
Great.
Okay. Let me know if you can see my screen. Can you?
Yes, yes.
Okay. Great. If you can see it, then I think I can start. As it was introduced, I am Alain Ndoli. I work with IUCN now in Rwanda. The work I'm going to present to you is one of my research topic that I did back in 2000, from 2013 until 2016, and it was published in Field Crops Research. It's entitled Disentangling the Positive and Negative Effects of Trees on Maize Performance in Smallholdings of Northern Rwanda. So to start, as you know, most of our population in the country depends on firewood for cooking energy and also for other uses, but mainly the firewood is a big demand. While in rural areas, they mainly use, traditional three-stone stove. In cities, they use charcoals, and you can see that charcoal is not the best as well, because it contributes to deforestation. Another challenge is the biomass from the fields, which involve a lot of trade-offs. After the harvest, farmers really prefer to take all the biomass from the fields, and they remain mainly with the limited organic cycling in the fields. So all of this brings about land degradation that has been, trending over the last 2 decades or so. A lot of deforestation has happened, and a lot of low organic matter recycling. This was it's not only the case for Rwanda or the northern part of the country, but it's really common in most of our African countries. So then with land degradation comes environmental pollution, like a lot of erosion and sedimentation into river streams and lakes. Very, very limited yields when we have degradation as well, what we call visual, or the visual indicators are those low yields. You can see the small crops that I was taking a picture here in some of the degraded areas. but also the scarcity of these firewoods, because then students have to, miss some school hours to go fetch for firewoods, long distances, and all starts is actually like an effect, a negative effect from all this degradation I was trying to explain. So I know most of you might be familiar with the country, with Rwanda. So this cycle of degradation has been going on for several decades. And now good news is that we are starting a decade of ecosystem restoration, endorsed by UN. IUCN is a partner. And we hope the Center of Excellence in Biodiversity will also be always joining us in all of these efforts. So the study objective was mainly to unravel the process involved in tree crop interactions. We have been doing a lot of now restoration. This is a picture of some place in Nyabihu towards the Lake Karago, where ICRAF and some partners at the government of Rwanda, Ministry of Environment, have been doing restoration. And it also touches to the other side of Gishwati, which was restored, put under restoration, where a lot of eucalyptus, Alnus acuminata and Markhamia lutea have been planted in farmers' fields called agroforestry. So I will not go more into the definitions. So we were trying now to understand what are the negative and positive effects of these trees on the overall system productivity, but mainly on the effect on crop yields, because farmers are more interested in crop yields, and those are just farms. They are farms. They are their own source of livelihoods. So we had hypothesized that improvement of soil fertility by the trees could compensate the negative effects of shade in these farming systems where little mineral fertilizer is used. As you know, Rwanda is one of those countries, still not using quite a lot of fertilizers compared to the other scales. So I think now we are around between 10 to 15 kg per hectare on average. So trees really present a great opportunity for a sustainable nutrients input and recycling while limiting for all these chemical fertilizers. So our hypothesis was that trees would contribute to more fertility and more crop yields in these small holdings, as it was the initiative, of course, when restoration was taking place in the area. Great. So our research methodology, if I would just summarize, the study took place in Rubavu, as we'll say. It's in Nyakiriba sector, Gikombe cell. It's just near Mahoko village. The Mahoko village is on your right when you see the other side of, which used to be Gishwati forest, actually was degraded and farmers had cut all the trees. But now restoration was taking place and more trees had been planted in farmers' field. It was really a good experimental site to explore. Great, so we laid out an experimental setup which uses mature trees of Alnus and mature tree of Markhamia lutea, Musavi in Kinyarwanda. It's actually an indigenous species to the region. We took one plot of a sole. I don't know if you can see my cursor, but sole tree, one tree without any crop, and we placed 2 loggers of access tubes at 1 meter and 3 meter from the tree stand. We took another plot with the similar tree characteristics and also set the same loggers 1 meter from the tree trunk and 3 meters away. And we also took in the same fields, in the same farm, we took a sole plot without tree, but belonging to the same person for common or similar management or history of fertilization and so on, to compare the three treatments on several parameters that I'm yet to explain. So we also set a temperature logger. I was using tiny tags that you can cover with a small plastic material and put it under the tree, under the canopy, and also put one in open field, actually 40 meters from the tree, any tree. That was actually the setup in the fields, and we replicated it 3 times for each species in the area. So without further ado, I would like to, because the paper was really too long, because I had a lot of measurements right from the germination, the emergence rates. We were counting the number of leaves, how their appearance rates, their diameter and the length. So there are quite many parameters you can find in this paper. We'll share it maybe after the presentation, but you can still Google and find it on my ResearchGate account. I just have chosen a few results to discuss with you on my conclusions, because I know the debate is still open and we are carrying out more research in the Eastern Province now to prove some of the concepts and find some better managements that can be recommended. So in the results, I would like to start with the light measurements, because we, as you could see, we did quite several measurements. I could put some weather stations under the tree and away from the tree and record simultaneously the radiation. That's what I call cumulative daily radiation, but away, that's just away from the fields. And we have cumulated rainfall in open fields. I will show the data now in the agroforestry systems later on. But my evaluation went to 4 seasons, 4 agricultural seasons. You know, in Rwanda, we have 2 main ones in a year, the season A and season B. So I did continuous maize for the 4 seasons. And this is the cumulative rainfall over the growth period, while this is the cumulative radiation over the growth period of the maize. You can see that one of the season had really high rainfall, while we had one with also very low rainfall. We shall see later on some effects on the yields and water balance and other things. So to start with, one of the conclusions in my analysis was that Alnus acuminata recycles more nutrients than Markhamia lutea. They are both evergreen trees, but Alnus had more leaves and was giving a lot of litter fall. We had some buckets to capture the litter fall in the tree alone treatments. And we found out that in the 4 season, we could get from the litter fall that we collected ranged from 2.43 tons per hectare dry matter to 0.52 tons. And then we could measure the nitrogen and phosphorus, which are in the litter, and could see that one of the season, which was dry, the 2014B, had the highest, 2014B, which is this one, okay, had the highest litter fall and then the highest nutrient inputs in the system. So for Markhamia, the trend was the same, but the dry matter from the litter fall was very low compared to the Alnus trees. And of course, the associated nutrients were also not much. The nutrients uptake, sorry, it's a small mistake. The nutrients uptake by maize was higher in Alnus acuminata system than in open field and also in Markhamia system. We found out that a significant effect of distance from the tree trunk was observed for nitrogen uptake by crop growth, and by crop, grown in Alnus acuminata, under Alnus acuminata, more at 3 meters than at 1 meter. Because at 1 meter, the yields were a bit limited because of, we shall see too much competition for other factors, but the yields were increased, were quite almost similar to the open field at 3 meters or even higher than the open fields. So these results suggest that though Alnus acuminata increased the available nitrogen through liter 4, the shade effect reduced the uptake at 1 meter. Because when we measured the nutrients input versus the biomass at 1 meter that was produced for maize, we could see that there was competition. So at 1 meter, the yields were quite reduced, but at 3 meters, actually the tree compensated for what was reduced at 1 meter. So I just didn't have the original table. I had to copy it from the article right there. So if we go then for the microclimate effect of the trees, in this area we had quite a lot of rainfall, and the soils were rich in organic matter and could hold quite enough soil moisture. But nevertheless, when we measured soil water content from 0 to 40 centimeters and from 40 to 100 meter depth at maize alone, Alnus alone, and Alnus plus maize, we could see that maize alone, which is this bar on the top, the second from the top, and Alnus and maize were not quite different. So we concluded that, and the trend was the same even from Markhamia. We could see that these ones with the dark triangles and dark cycle, they are for maize or maize with a tree. It showed that trees had not affected the soil moisture in any way, but the practice was affecting. For instance, Alnus alone was showing here low soil moisture content when it was only Alnus alone, but we presumed that because we did it till and there was too much runoff, if we could have tilled, maybe this one would also have matched the other lines. So the trees, the blame of the trees that they could compete with crops on soil moisture in that other area was not approved. We found that these trees were not competing with water because water was enough for the trees and also for the crops. Maybe this could be different if we go to the Eastern Province, but at least this context, there was no competition found. Then again, microclimate, the radiation and the air temperature, we measured the photosynthetically active radiation at a distance from the Alnus tree and from Markhamia. This is actually the standard from open fields, and we realized that the photosynthetically active radiation was increasing as we go from the tree up to 3 meters and then to the open. What does this show us? It shows us that though at the canopy edge, which was mainly at 3 meters, it's the place where we don't have the full sun, not the full shade, but in the transition. And this shade was not, I would say, bad to the crops. Though maize is a C4 plant and requires a lot of radiation, this was not depressing the yield at 3 meter distance. It will come back in the conclusion, because if we could prune to keep at least 800 mole per meter square per second, this the under tree area could all be cropped with no competition for light. So we also set, as you could see from the picture, some weather stations. They are Davis integrated sensor suits that I placed under the tree and away from the tree for a couple of weeks. And we found out that under Alnus, solar radiation was quite much reduced. I have some other paragraphs, other graphs that show differences and the reduction capacity of the canopies, but I chose to present this because they are very visual than the other ones. So for Markhamia, you could see that from the morning, the solar radiation is not that different because of mainly the angle, but also the smaller canopy. But towards midday, it's where we get the most of the difference. And then we get, again, almost similar radiation towards the end of the day. We can see also that from our air temperature loggers that under Markhamia, under open fields, in open fields, we had more temperature towards the midday. But when the day starts and the evenings, temperature were almost the same. But with Alnus having lower temperature during the midday, because of canopy shade and there could be a breeze. And this also had an effect because the degree days were delayed. It's on other parameters, maybe that I will not manage to present here. We had fewer degree days and the crop could take some longer on 1 meter. And then the maturity was not yielding more grains as expected. So what do we conclude on this is that both Alnus acuminata and Markhamia lutea reduce incident light and day air temperature, which reduced maize height. We were measuring the maize height every 3 days from at different distance from the tree trunk. And under the tree, we had really stunted maize, but at 3 meters from the tree, the maize were very tall, even taller than open field, showing that there was a kind of a fertility island that was created around the tree. Again, if I can move to the yields, we found out that at 1 meter yields were reduced for both Alnus acuminata and Markhamia lutea. For Markhamia lutea, even at 3 meters, we are still having some competition because of dense rooting systems and little nutrients recycling. But with Alnus, we could see that the fertility effect of Alnus could at least compensate for the yield loss at 1 meter. Great. So I don't want to go into details of the yields and the biomass, but the overall conclusion, as I will go to the conclusion below, was that actually our hypothesis was approved only for Alnus and at 3 meter from the tree stand, that the tree could compensate through the fertility inputs for their light competition. I chose to also add this graph. We also did the simulation using AppSim, not AppSimX, but the AppSim normal, trying to see different scenarios of what would be the yield reduction if we play around the nitrogen inputs and also the radiation and temperature, because those were the 3 major contributors to the yields in the agroforestry system. So we realized that, if I can go there, if we increase nitrogen and do inputs of 114 kilograms of nitrogen without changing the radiation and the temperature, yields will still increase at this level. But if we take half of this and reduce the radiation and reduce the temperature, reduce the radiation by 10%, trees were reducing the radiation from 10 to 20%, while the temperature was reduced almost like 2 degrees from the max. The max was received at midday. We could see that then the yields would also reduce at the maximum. However, if we could have the inputs of nitrogen from the trees and yet reduce the temperature and radiation, we would not go to the maximum yields, but our yields would be the second. So we found that the business as usual, which is this one, normally farmers apply 64 kilograms in open fields. There's no radiation reduction, no temperature reduction in open fields. So their yields was this one. If we could model it, the probability of being below what was received was this one. So to make the story short, this graph, the triangle here, is actually the scenario for Alnus. Because Alnus itself added this amount to the 64 kilograms that was normally used by farmers, though it reduced 10% radiation and 2 degrees from the maximum temperature, the yields could still be better than what is done by in business as usual without trees in the fields. So for conclusion, sorry, I see some of the charts. I was not. I will respond to the question a bit later, maybe. Okay, then we conclude that a positive interaction between Alnus acuminata and maize was only apparent at 3 meters from the tree in one of the 4 seasons following higher litter fall. Other seasons, the yields was similar to the open fields. It suggests that the negative effect of shade was offset by extra nitrogen inputs from Alnus acuminata. We also conclude that trees may increase soil fertility, but their shade prevents crop from fully benefiting. Hence, the need for better tree management, especially in this other region where solar radiation is not intense, like in Eastern Province. They have too much rain. The skies are most of the days too cloudy. So pruning should be one of the best, the priorities in these farming systems. Then what remains to investigate is mainly when and how much to prune, depending on the crop you want to grow beneath. We also found out that unpruned trees some of the farmers don't want to prune at the right intensity because they want to produce more stakes for the coming season for the beans. They grow more in this region, the climbing beans. And you could see from this picture, for instance, that how much stakes they really need. Some of the dark ones you can see are from Alnus, but the white ones are from Penicetum. So you can't really find enough, and it's one of the heaviest investment for climbing beans. So unpruned trees, for the sake of stakes and other tree products, might be grown at the expense of crop yields, and farmers' priorities determine the balance of crop and tree products they want on farm for a given season. Allow me to wide from there and maybe open for questions and answers, and maybe we can derive for some more topics which could be investigated going forward. Thank you very much.
Yeah, thank you, Alif. Thank you for the good presentation. There might be some questions in the chat room, and I see there's the first one was asking if can this study be done in other areas of Rwanda, as this one has been conducted in eastern part of Rwanda, and we want to know if it can be applied in other regions. There is also another question about why did you choose Alnus acuminata and lutea while learning about maize performance? And another question is, can also be applied to other crops rather than maize? You may start by answering these questions or giving more clarifications. I invite other participants here present maybe to ask questions openly.
Okay, would you want me to start by answering this, or?
Better you start by answering
more?
these ones, and then we get more from other participants.
Great. Yeah, the first question on whether this study can be done elsewhere. Yes, it can be done elsewhere. And I've seen more interest in people trying to also find a similar kind of study in the Eastern Province. But I also did almost a similar setup for Grevillea lutea in Bugesera and Senna spectabilis. But the results were very interesting that we chose to publish them in Global Change Biology. Maybe some of the time I can present this. It's we combined the data from Rwanda with 7 other countries in Africa. And the title is called Modeling Climate Change Impact on Maize Yields Under Low Nitrogen Input Conditions in Sub-Saharan Africa. So I will copy this maybe and drop it to the chat so that you can maybe read it later on. This is the title of our publication in Global Change Biology, which is actually a good journal with 9.2 impact factor. So it can be done to be short, but yeah, they may be doing more of system-wise than just tree crop soil interface. And some of our students who are funded by IUCN and through EU projects have started doing the same. Another question was, yeah, thank you for this interesting research. Why did you choose Alnus acuminata and Markhamia lutea while learning about maize performance? Great. So Alnus acuminata has been shown by quite more studies that they are the most dominant tree species now in farming systems in the Northern Province. I mean, the west north of the country. We have done, when I was still with the World Agroforestry Center, a study on tree-based ecosystem approach. It's called Taking to Scale Tree-Based Ecosystem Approach, and I was just trying to take again I'm copying the title and also dropping it to the chat. So if you follow this one, you can find that the studies show that in the northwestern part, Alnus is the most dominant. But I didn't really want only to work on Alnus. It's not indigenous, yes, but also it's in the coming days it's going to be like a eucalyptus in that area. So I tried to find the second dominant tree species in the area, and Markhamia was most prominent. So I took Markhamia lutea that way. The study can, if you have means, you can go to other species, but these were quite dominant in the landscapes where I was working in. Again, you said while working with maize in that area, they are after maize and beans. And the government has been, subsidizing maize hybrids, and they want it's our politics. We really want to increase the calories per unit hectare to feed the ever-growing population. So that's how I chose maize. I could also have done something on beans, but there were a couple of other IITA and other initiatives which were working on beans. And the biggest gap were on maize. And that was my motivation. So maybe Lucy will tell me where she wants it to come to. Can also be applied to crops other than maize. Yes, it can be applied when used to other crops, and they would respond much better than maize actually, because maize is a light hungry plant. It really requires full sun to be able to photosynthesize and generate the much biomass we want, especially those hybrids that are used by the local communities there. They normally use Pan 67 and Seedco, the long full season seeds. Great. So I think I have exhausted the questions in the chat.
Yeah. You have answered all the questions in the chat. Let us give time to other participants here if there is any question, intervention, support for this research. If anyone wanted to intervene, he's welcome. She's welcome. Gatesi, you raised up the hand. Come on, please.
Thank you very much, Dr. Ndoli, for your presentation. I would like to know, there is a way you have mentioned the effect of nitrogen fertilizer application, suppression of maize yield under Alnus lutea. I would like to know if you have correlated this suppression with the other factors like antagonism with the other nutrients in soil, like phosphorus, or only if it is attributed to the presence of Alnus in the field. Thank you.
Yeah, thanks very much, Gatesi, for the good question. Actually, when you are doing research, you try to, especially in these complex systems where everything interacts with everything, you need to narrow down your scope so that you can have inferences. For instance, we realized that nitrogen and phosphorus were the limiting factors for the crop production in those systems. In the low nutrient input systems, nitrogen and phosphorus, all the modeling we did with CREFTs, we were finding that nitrogen and phosphorus were the biggest issue. So we were just working in the nutrient deficient system. So when I was calibrating my APSIM model, I also did inputs in the initialization of the model, the phosphorus and the nitrogen and potassium, but also the carbon and other inputs. But I couldn't do the interaction of all these nutrients at a go. I chose to use nitrogen because it's the quickest win. I know, for instance, some of the reviewers were asking me, oh, maybe this is not only from Litafor, it could be from nitrogen fixation from Alnus. And I was like, yes, maybe yes, but I didn't have the means to really disentangle again what was from the biological fixation of from Alnus and what was from the litter recycling. So to cut the story short, I chose to model the nitrogen variations and also the radiation and temperature as they were the biggest players in the yields. So the biggest sensitivity in the model were linked to those factors.
Great.
Okay, thank you
for the feedback.
Thank you. I have maybe the other small question. The study was conducted in Eastern Province, right?
No. In Rubavu. It's near Gishwati. That's where Alnus are. Normally, Alnus are not in those mid-lowland areas.
Yeah. Okay. Okay, thank you.
Good. Thank you, Ndoli, for the feedback, and thank you, Gates, for the question. Another question from the participants, from the audience?
Yes.
Go ahead, please.
Thank you, Ndoli, for the nice presentation. I would like to know how long did you take to choose the plant? You said that the tree will mature. So how long did you take to start planting so that you know that those trees are mature? Thank you.
Thank you very much. I guess it is Antoine. Actually, in agroforestry research, we have quite big gaps in mature systems. You find a lot of PhD students, a lot of researchers, they set up the experiment with a project that lasts in 4 years, and the measurement stops at maybe they plant in the toward the end of the first year, and then all the measurements stop at the 3rd year. So I took trees which were between 5 to 6 years in this system, and we have in the paper the characterization of the trees, the canopy, the height, the diameter, and the management they have been going through. So those ones were the ones we considered kind of mature, because farmers were telling us that after 4 years, those trees will be cut down. So we started when they were like 4 years, and then at 8 years, they were like at the epic of their existence. Some farmers were preferring then to even harvest them.
Okay, thank you.
Okay. Good. Another question, if there is?
Yes, please.
Yes, go ahead and ask your question.
Thank you, Dr. Alain, for a good presentation. My name is Vestine. I just want to ask about Markhamia. You said when in the plot where you have Markhamia at 1 or 3 meters, it didn't perform well. Why do you think this trees is it adopted while it shows this trend of reducing yield? Thank you.
Good. Vestine, thank you very much. Actually, I was going to say that's a story for another what if, because we also did some root studies trying to understand the architecture of the roots beneath, but I couldn't present everything here. So Markhamia was having also quite extensive rooting systems, but good enough, its wood is traditionally known, and in that area, for instance, Kiaka, this company that does the mopping things, lacrete, I don't know how we call it in English. So they were giving them, you know, this big market of providing the bottoms for these things, and they have also big market for the wood from Markhamia. So traditionally, they have been keeping Markhamia while even uprooting all the other indigenous trees. So Markhamia were really maintained and kept in the landscapes. So I didn't go much into details of the use, but farmers are rational on why they keep things and don't adopt others. I trust those are the two main attractiveness of it. One is it has a straight stem and it can provide good wood, and they had a market in the nearby.
So this means you can't say it's contributing maybe to soil fertility in terms of green manure and whatever. Only it's preferred because of that part of using it in the Kiaka product and what.
Yeah, yes, it does contribute, because I showed also the tons of biomass it contributes per year per tree, yeah. But it's not at the scale of those Alnus, which really gives a lot of green manure, and you know it's flourishing. But yes, it has the leaves, but it maintains the leaves. It's an evergreen as well. And yeah, nutrient recycling is a bit limited. If you are just there for fertility, immediate fertility, it could take really long.
Okay. Thank you very much. I was asking this because I'm really interested in these indigenous trees, if they can be adopted as agroforestry trees that may help to improve soil fertility. So it's very interesting. Thank you.
Thanks very much. Yeah.
Good, thank you. Any other question? Let us see in the chat. I think in the chat there is no other question. Let us see from participants if there is a question or intervention. Any person with a question, intervention, suggestion for Alain to improve the work maybe? I can't see any intervention from the audience. This is a sign that we are almost at the end of our seminar. Allow me to thank everyone, starting from the presenter of today, Dr. Ndoli. You have done a fantastic work, and you are welcome any other time to present the remaining data. As you told us, you could not present everything in this seminar. And before I close, I would like also to invite other people who might want to present, to be in touch with Vena and Joseline, so that we schedule you for the presentation. Allow me to thank you very much and say goodbye, and we shall meet next time, the same hour, for our next seminar and our next session. Thank you and bye.
Thank you very much for the opportunity. Bye.
Bye.
Bye.